There we go. Okay, so we are in chapter 8. And just to give everybody a chapter 8 review, not to have you watch me crazy scroll, but I just want to make sure we all know where we're at, what we've done so far, and hopefully you're working through the homework and it's making sense for you. So chapter 8, the first section was about inverse variation. So remember, direct variation is when x goes up, y goes up. And in 8.1, we talked about inverse variation. So when x goes up, y goes down. And we actually get a curve that's that looks like kind of like an exponential curve. Hey, Olivia. So we have inverse and joint variation that we talked about. We also then spent 2 sections, one online and one in person, talking about graphing rational functions. So remember, when you see a rational function, that's the same word as ratio. So these are, we have, in many cases, we have a function on the top and a function on the bottom, and so it's a ratio of one to the other. Hey, Noah. So we figured out how to graph them, and then we figured out how to find the domain and the range, as well as where the asymptotes were of our equation, right? So we did that in 8.2, and then we did that again in 8.3. We found the domain and the range. These were a little bit more tricky because sometimes we could have an asymptote and sometimes we could have a hole in our equation, depending on if we factor it out or not. So then we moved on to multiplying and dividing rational expressions, which this one is kind of the easier of the two. This is where we would factor out certain terms so that we could simplify our expressions. On Monday, we talked about adding and subtracting rational functions or rational expressions. So again, just like our fraction rules, for regular old fractions, you have to have the same denominator. And if we don't have the same denominator, like these two, 5 and 6, then we need to make them have the same denominator by finding the least common multiple. All right. So all of that to say that our last section is called solving rational equations. So now we actually, if you noticed, all of those that I just scrolled through didn't have an equal sign in them. So we weren't actually trying to solve for x until this section. All we were trying to do is either simplify or understand or whatever it might be. So now we're getting to the point where we can actually solve our equations. Yay, right? All right, so we shouldn't, we should be able to use the tools that we already have to kind of get through this, okay? So we talked about on Monday how you would do number 1. I think Kirsten said cross multiply. I think that's the first thing you said, right? So we talked about that for an equation that has an equal sign, when you have one ratio equal to the other ratio, the first thing that should pop into your head is cross multiplication, because that's probably going to be the easiest thing that we're able to do, right? So just a really, really quick review, because I don't want you to watch me do it forever, but we would cross multiply by doing 3 times x minus 7 equals 2 times 5x. Okay, and so remember this x minus 7th, you want to keep in parentheses because that's a whole value there, right? And that means that we're going to have to distribute our 3 in order to get rid of the parentheses. So we would have 3x minus 21 equals 2 times 5x is 10x. We'd subtract 3x from both sides. So this is where you get to bust out all of your algebra skills, right? Negative 21 equals 7x, or x equals negative 3. So we did that on Monday. That's why I did that really quickly, right? So let's look at number 2. Number 2, is that not what I want to try? Is number 2 the same scenario as number 1? And what I mean by the same scenario is it a ratio equals a ratio, a fraction equals a fraction? And it is. It's a fraction equals a fraction. So we can actually solve this using cross multiplication. This one's a little bit more complicated, but we can still do it, right? So we can cross multiply this way. Let's do that. Nope. All right, back to there. We can cross multiply this way, right? First, and we get 1 times 11x plus 8. Well, that's nice and easy. 11x plus 8 times 1. All right, and then when I cross multiply the other way, I get x times 2x plus 5. Okay, so if I do this, everybody okay with that? Is that all right? I'll make this my parenthesis. Could everybody see everything okay? I should have asked that before I jumped right in. Okay, just making sure. I'm like, I'm just talking away here. All right, good. Okay, so 11x plus 8, and then what do we have to do over here? We got to distribute this guy, right? So we get 2x squared plus 5x, and then we have 11x plus 8. So how are we going to solve this quadratic problem that we have here, right? This isn't quite as easy as number 1. But we still can do it, right? If we can get our quadratic equal to 0, then we can either solve it by factoring or using the quadratic formula. Remember, we learned how to do both of those? So what we're going to do is we're going to subtract 11x and 8 from both sides of our equation. And we'll end up with 0 equals 2x squared. And then I have 5x minus 11x, so minus 6x minus 8. Okay, so this is now we have a quadratic equation equal to 0. And back in your math archives, you should be thinking, oh, good, because now I can solve this using factoring, or I can use it with the quadratic equation. Quadratic equation. I can do either one. All right, I'm going to go ahead and solve it factoring, so I don't have to do the big quadratic equation, but you could do the quadratic equation if you want. The first thing that I notice is that each of these has a factor of 2. So if I factor out 2, I can make my life a little easier. 2x minus 3x minus 4, okay, equals 0. So then I have 2 equals x. So I'm trying to factor this, right? I need a negative 4 and I get a negative 3. So if I have a negative 4 and a positive 1, oops, I forgot my x, then I will be able to factor my quadratic, right? And sorry, this is crazy. I can't even read my own writing in here. This should say x plus 1. It's much better. Okay, so now that I have this that equals 0, I know that either x minus 4 has to equal 0 or x plus 1 has to equal 0. And so x could either equal 4 or x could equal negative 1. So I actually end up with 2 solutions to my original equation. Okay, so if I was taking a test and I wanted to check my work really quickly, what would I do? I would not go to my email. I would go to Desmos. And what do we have here? We have two ratios that are equal to each other, right? So in theory, if I graph the left side of my equation and the right side of my equation, the spot where they're both true is where they both do what? Where they both intersect each other. So this is, the red is my left side of my equation. The blue is going to be the right side of my equation. Okay. And if I look at my graph and I see where they intersect, I see that they intersect when x equals -1, okay? And they also intersect when x equals 4. If I zoom in a little, you'll be able to see better where they actually intersect. X equals -1 and x equals 4. So when you have this is true for anything that you have an equal sign. Whenever you have an equation with an equal sign, you can put it in and pretty easily see what the solutions will be. Not that you can necessarily solve that way. You have to know how to do it another way, but you can check your work pretty easily by doing that. So kind of keep that always in your back pocket. Oh, I can always do that, right? Okay. So let's keep going, unless anybody has any questions. You guys all right? All right, let's keep having fun solving our equations, right? Okay. So let's look at number 3 and 4. 3 and 4 are similar. I am going to show you 2 different ways to solve 3 and 4. Okay, so the first thing, let's look at number 3. The first thing that you're going to notice about number 3 is that I have 7/2 plus 3/x equals 3. So can I solve this using cross multiplication? Is it a proportion? That's the word I should have said earlier. Is it a proportion? Is it 2 fractions that equal each other? No, right? Can't do cross multiplication because we have 7/2 plus 3/x. So you can't cross multiply. Exactly, Otto. Can't do it. All right. So we got to do something to get our fractions to add together so that we can do cross multiplication. So this is option 1 for how to solve this equation. Okay. So I have 7/2 plus 3/x equals 3. Okay. So option 1 is I can find the least common multiple of 2 and x. So this happens to be a really easy least common multiple because the least common multiple of 2 and x is 2 times x. Pretty easy one, right? So what you're going to do is you're going to take your equation and you're going to multiply it by your least common multiple, right? But because it's equation, if I multiply the left-hand side, I have to multiply the right-hand side too. Yeah, you can't just randomly multiply by 2x. Okay, so then I'm going to need to distribute. Okay, so I'm going to have 2x times 7 divided by 2 plus 2x times 3 divided by x equals 3 times 2x is 6x. I promise it looks a little more complicated, but I promise it'll go easier. Okay, so now what I notice is, oh, by multiplying by this least common multiple, I get to cross a 2 and 2 out here, and an x out here, and I'm left with 7x plus 6 equals 6x, right? If I subtract 7x from both sides, I get 6 equals -x, or x equals -6. Okay, so I've solved it. Yay, right? Did that make sense to each other? So by multiplying by the least common multiple, I'm able to make my denominators basically disappear. I get rid of my denominators and I get a nice equation that's pretty easy to solve. So this least common multiple gets rid of your denominators and gives you a nice equation. Okay, here's option 2. sometimes you don't get option 1 and option 2, but for this particular problem, there is an option 2. Okay, so option 2 is I have 7 over 2 plus 3 over x equals 3. Okay. I know I have this 3 over x. I'm going to kind of leave that alone. But I notice here that 7 over 2 is just a number, right? 7 over 2 is 3.5. So I could also, instead of doing this method, let me give myself some extra space over here. Since 7 over 2 is just a number, what if I subtracted both sides by 7 over 2? Okay, so if I did that, I have 7 over 2 plus 3 over x minus 7 over 2, so I'm left with 3 over x equals, and then I've got 3 minus 7 over 2. So let's do a little fraction work off to the side. 3 is the same as 6 over 2 minus 7 over 2, which is negative 1/2. 3 minus 7 over 2 is negative 1/2. So when I did that, what is this all of a sudden? What is this thing that's in the red box? Now I have a proportion that I can solve by cross multiplying. Okay, so now I can say, oh, 3 times negative 2 equals, and then the negative, I'm just assigning to the 2. 3 times negative 2 equals 1 times x, or x equals negative 6. So sometimes you don't get the option to do option number 2, because if this, for example, had a x in it also, if 7 over 2x, then you wouldn't really have that option. But because it's 7 over 2 is just a number, you could solve it that way as well. All right, so if you could pick, what would you pick? Would you pick option 1 or option 2? Or option 3? Neither one. I'm just kidding. Which one would you pick? Option 2 if possible. That's what I would pick too. A little bit easier, but we do have to know how to do option 1. Okay, so what I would like you guys to do, and I'll start doing it on here, but I'm not going to talk. I want you guys to try to do number 4 and pick either option and tell me when you're done. So try number 4, which is 2 divided by x plus 4 divided by 3 equals 2. Oh, wait, before you even try it, sorry, really quickly. Again, you can quickly check, again, if you were doing a test. So if you're doing a test, you shouldn't get anything in this section wrong, because you can check to see if you messed up, right? So one side of your equation is this, and the other side is y equals 3. Okay, so if I pull this back, I need to see where they intersect each other, which happens to be out here when x equals negative 6. So I shouldn't get any of these wrong. All right, now try number 4. And I'm going to clear some of this off, and I'll start doing number 4. All right, I'm going to start doing number 4, sorry, up on here. Okay, so I did option 1 and option 2 up on here. If you were going to do the least common multiple, you would do 3x and multiply both sides by 3x. And you should end up with 6 plus 4x equals 6x, which gives you 6 equals 2x or x equals 3. Okay. If you just subtracted the fraction, you actually end up with 2 over x equals 2 over 3. So then it's pretty easy to see that the solution is x equals 3. Did everybody end up with that? Awesome. Okay, so one more. I think 1, maybe 2. Yep, just one more. Okay, what about number 5? Okay, so can I cross multiply just like this is? Can't cross multiply this, number 5, like it is, right? Because you have the plus sign. So you can't do that. So we need to somehow either create a proportion, which is one ratio equal to the other, or we can get rid of the denominators. So for number 5, we actually have 2 options again. Okay. The first one, we're going to find the least common multiple of all our denominators. So in our denominator, we have a 2 and we have an x minus 1. So the least common multiple of 2 and x minus 1 is 2 times x minus 1. So I'm going to take that least common multiple and I'm going to multiply it by both sides of my equation. So I have 2 times x minus 1 times 3 over 2 plus 4 over x minus 1 equals, I have to multiply this side too, right? 2 times, sorry, I don't even know what's happening there. There we go. 2 times x minus 1 times x plus 1 over x minus 1. All right, well, this is good. Those at least crossed out over there, so that's good. All right, so when we distribute, right, we get 3 times 2 times x minus 1 over 2 plus 4 times 2 times x minus 1 divided by x minus 1. So let's at least cross some stuff off. All right. So here we get to cross this and this off. That's good. Here we cross this and this off, and we're left with 3 times x minus 1 plus 8, right? 4 times 2 is 8, equals 2 times x plus 1. So what do we have to do now? Now we have to distribute, right? We'll get 3x minus 3 plus 8 equals 2x plus 2. That's a 1, not a 7. All right. 3x minus 3 plus 8 is plus 5 equals 2x plus 2. Let's just keep going, right? Subtract 2x from both sides. And now it's just math. X plus 5 equals 2, or x equals negative 3. All right, whew, that's a lot of work, right? So how could we check that we did that right? Well, by the way, if you don't happen to have your calculator with you, what's another way you could check that this problem's right? You could plug it back in, right? You could plug it in and see if you get the right number when you put x in for that. I can also graph it. If I happen to have my graphing tool, I can graph it to check. All right, I need to know when 3 divided by 2 plus 4 divided by x minus 1 equals, and this is where you're going to have to be careful if you have your TI, x, make sure you get parentheses in there, x plus 1 divided by x minus 1. All right, so where are those both true? I can see a spot already popping out right here, and that is when x equals negative 3. Okay, so that's true. So I said that was one option. Does anyone else, when they see this problem, think of a different way that they could do it besides multiplying by the least common multiple? Anyone else have something that popped into their head? Yep, exactly, Otto. So let me, not what I want to do. Let me do this. So option 2, I'll just erase a little bit of this. Option 2 is that you could notice that this second fraction and the third fraction have the same denominator, right? So if I take my original equation and I leave 3 over 2 on one side, and I subtract both sides by 4 over x minus 1, so I subtract the left and the right by this, I'm left with 3 over 2 equals x plus 1 over x minus 1 minus 4 over x minus 1. Does that make sense? Okay. Cool. So now I can do, the denominator stays the same. It's x minus 1, right? The top becomes x plus 1 minus 4, so it's x minus 3 over 3 over 2. So I could then cross multiply, right? Because I've gotten rid of any of my pluses. I'm allowed to cross multiply. So I get 3 times x minus 1 equals 2 times x minus 3. And I end up with 3x minus 3 equals 2x minus 6. Subtract 2x from both sides, and I get x minus 3 equals minus 6. And when I add 3 to both sides, I end up with x equals negative 3. Okay, so I end up with the same solution, just a different way to do it. Either of those would be acceptable. Okay? So, how do you guys feel about that? Is it doable? I think you guys can do it. So that is all there is for chapter 8. We finished up chapter 8. So what I want you guys to do is I want you to work on the homework. I am going to send out the test. Everything will be due on one of these days if my calendar pops up. Everything will be due on March 4th. So you'll have a week and a half to finish up your homework and work on your test. We will start chapter 9 on Monday. So obviously, as much as you can get kind of wrapped up, the better off you'll be as we start chapter 9. So that is all I have for you guys today. So if you have any questions, I'm happy to stay on and do homework from any of the sections. If not, you are welcome to go and work on your homework or anything like that. All right. Thanks, guys, for coming. Have an awesome day. Thanks. Bye, Otto. Have a great day.